And so another thing that could happen when we're talking about solving systems of a quadratic and a line is there may only be one solution. Okay, and again, just kind of a generic example. I've got a quadratic there. I've got a line, and you can kind of see how this line just kind of comes through and just barely touches that quadratic, touches that one nice, neat little point there, and boom, and then it's on its way. Okay, so it's not going to slide inside the quadratic at all. It's just going to just barely touch the outside and just going to kind of keep moving there. So it is possible that a a line and a quadratic only touch once, and it doesn't have to be a horizontal line just touching the vertex. A line can be just barely scraping through on the parabola there. Maybe from geometry class you talked about a tangent line, maybe a line kind of barely just brushing through a circle. Finding the equation of that or whatever you did with that, but this can also be referred to as a tangent line there. Okay, so again, I have an example. I've got a quadratic here as my blue equation. I've got a linear equation in green. Again, we see that the y is isolated on a side, so this is going to allow us to use that equal value method. Okay, and I went ahead and already set that up for you there. I've got my blue quadratic on the left. I got my green line on the right. Now it's our job to solve here. Okay, we got to solve for x. So again, whatever route you want to take, understanding you're still dealing with a quadratic. You can factor, you can use quadratic formula. It does not matter. Just pick your favorite one or whatever one is easiest for you. So again, we've got to get this zeroed out. So everything on the right here, right, the x squared term here is positive, so I'm going to leave him alone. I'm going to take everything to that. I'm going to subtract the 4x. This 7's a negative, so I'm going to add it over. Okay, so now I'm going to combine my like terms. I've got x squared. 10 minus 4 is a positive 6. 7 plus 2 is 9. Okay, so now that I have it zeroed out, right, now we can use our zero product property in factoring, or we can use our quadratic formula. So one thing you should notice that the a value is 1. We've done a lot of practice with this. When that a value is 1, this becomes so much easier to solve. Okay, to factor, excuse me. So now the a value is 1, let's factor it. So all I need is my diamond. It might end up not being able to factor, so we've got to use our quadratic formula, but this shouldn't take us too long to kind of see, what multiplies to get 9 but adds to get 6. You should see that it's 3 and 3. Okay, so my factors are x plus 3, but you notice it's the same factor. Okay, so now that we only have one factor, we only have to use a zero product property for one. I mean, you could do it for both, but you're going to get the same result, right? So we're going to say x plus 3 equals 0. We're going to take the 3 away. X is negative 3. So remember, we're trying to find that point of intersection. This guy is going to have a point of intersection somewhere when the x value is negative 3. If you were to use a quadratic formula, hopefully you remember from last chapter, the discriminant should be 0, right? So when we take the square root of a 0, we're adding and subtracting that 0. It literally does the same thing. So if you do the quadratic formula, that discriminant or that stuff underneath the square root better be a 0. Okay, so now that I've got a value of negative 3, again, we need to find that point of intersection. So we've got to substitute that back into either the line or the parabola. Best case, substitute it back into the line. There's less work to be involved there. So I've got my line, the green equation, the 4x minus 7. So y is equal to 4 times the x value. We know what the x value is, right? We just found that to be negative 3 minus 7. Let's clean that up a little bit. So 4 times negative 3 is negative 12. Negative 12 minus 7 is negative 19, right? Okay, so now remember, it's a solution as a coordinate point. We've got an x value, we've got a y value. So the solution to this system of equation is you're only going to have one of them, and it looks like the solution here is going to be x negative 3, y being negative 19. Okay, so that would be the solution to this system of equation. And I went ahead and put this in my graphing calculator just so you can see it. So here are the two equations, right? We've got that blue quadratic, we've got the green line. If I hit graph on my graphing calculator, okay, you can see it actually looks very similar to the example that I showed you. Notice, I mean, we can get even closer to that, but notice how this line doesn't go inside the quadratic at all. It just kind of touches the outside and just kind of keeps moving a little bit there. Okay, so this guy is a great example of how you may run into a quadratic and a line system of equation only having one solution. Okay, so there's one more case that could happen with this, and I'm going to post another video. I'm sharing another video for you to be able to see what happens there.